Hi students, in this video we are going to have a full review of AP Physics 1. It is just going to be a quick run through on all the general ideas so that you can have a basic understanding of areas you're not confident in. I recommend watching this video first and then watch the videos on YouTube that talks about the specifics. Then come back to this video the day before or the morning before the test. And with all that being said, let's get down to business. The first unit in AP Physics 1 is kinematics. It is about particles moving in 1 or 2 dimensions. So first, you need to know the difference between a scalar and a vector, meaning whether something has directions or not. And the commonly used equations are going to be delta x equal to 1/2 at squared plus v naught t, v squared equals to v naught squared plus 2a delta x, and v equals v naught plus at. And these are going to be the equations on the equation t. And from these equations, we can derive the following, which is v equals delta x over delta t, a equals delta v over delta t. And thus, from these relationships, we can create graphs. So the slope of an xt graph is going to be velocity. The slope of an vt graph is going to be acceleration. The area between the curve and the x-axis for a vt graph is going to be the change in x. The area between the curve and the x-axis for an at graph is going to be delta v. And then in a 2D scenario, which is usually projectile, the vertical acceleration is going to be 9.8 meters per second squared during a free fall, meaning the gravity is the only acceleration vertically. And in a symmetric scenario, the speed is going to be the same when the particle has the same y. And then at the maximum y, there's going to be no vertical velocity. However, there's going to be acceleration that is constant throughout the projectile motion. And then horizontal velocity is going to be constant throughout. The way you can approach this is by dividing the scenario into 2 parts, going up and coming down. So you can either set Vy initial or Vy final as 0. And then in the end, you can multiply the time by 2 to account for the 2 parts of projectile motion. The second unit is dynamics. You have to learn how to draw an FBD. So you always go from the dot and away, meaning the force is acting on the particle. The commonly used equations can be found on the equation sheet, so we're just going to go over the Newton's laws in this video. The first law is an object will be in constant velocity unless there's an external force. The second law is just F net equals to ma. So from these 2 laws of motion, if Fg is the only external force, then the gravitational field g will be the acceleration, since mg equals to ma, thus a has to be equal to g. And then from the first law of motion, if the velocity is constant, then F net should be 0. The third unit is circular motion and gravitation. The most important idea in this unit is that there is a centripetal net force, meaning F net is equal to mv squared over r. And according to Newton's second law, a is going to be v squared over r. And in this case, the speed is going to be constant throughout the motion. However, velocity is not going to be constant because the direction is constantly changing since there's an acceleration centripetally inward. And then velocity is going to be tangential to the circular path. The typical questions are going to be like roller coasters. They're going to ask you what is the normal force, what is the Fg, what is the relationship between Fn, Fg, what is going to be the minimum velocity, etc. The second part of this unit is gravitation. You have to know the universal force of gravity, which is gmm over r squared, where r is the distance between the planets. So it's going to be from center to center. So in an FBD, although you can't really see it in here, but you have to draw from center to center. And the force of gravity is going to be centripetally inward. So the next unit is energy. Ug is going to be negative gmm over r, meaning as an object approaches the planet, the gravitational potential energy becomes more negative. And as the object moves further away from the planet, the gravitational potential energy will be reaching 0. So if it's infinitely far away from the planet, it's going to approach 0. So the graph between Ug and r is going to be a negative inverse graph. And Us, Ug on Earth, K are also commonly used energies. And we have to focus on conservation of energy. Conservation of energy means energy is conserved unless there's work acting onto the system. So work is defined by Ft cosine theta, meaning work is done by force or components of the force that is parallel to the motion. It is usually going to be a force of friction. TME, meaning total mechanical energy, is the potential energy plus kinetic energy. So thermal energy is usually not part of the total mechanical energy. The next unit is momentum. Momentum is defined by mv. It is like the oomph of an object's motion. So according to conservation of momentum, P initial is going to be equal to P final, and we can use the equation mv by saying mv initial is equal to mv final. The impulse, which is the delta P, can be calculated through delta mv, or force of impact times time of impact. So a frequently asked question is going to be like, in order to reduce the chance of breaking an egg when it is dropped, then what should you do without changing the initial velocity? So since the mass and the change in velocity are set, the impulse, which is the change in momentum, is set. So thus, in order to reduce the force of impact, you have to increase the time of impact. The next unit is simple harmonic motion. So this unit, I feel like you just have to plug in the equations. So the period of a spring is 2 pi square root of m over k, where k is the spring constant, and period of pendulum is 2 pi square root of L over g. A frequently asked question is going to be like, how will the period of oscillation change by increasing the angle between initial position and the y-axis of a pendulum? So although angle increases and distance traveled will be larger, this increase in potential energy, which is mgh, will also increase the speed, and thus the period will stay the same. We can also do this by plugging in the formula, which is 2 pi root L over g. So if L and g are not changing, then the periods should stay the same. Moving on to the last unit, torque and rotational motion. In this unit, we're going to use theta, omega, and alpha. However, if you multiply these variables by r, or the radius, you can get the variables in linear kinematics, which is x, v, and a. The difference between a torque and a force is that torque, which could be represented by the symbol tau, is equal to Fr sine theta, meaning only the force that is perpendicular to r, which is the distance between the force and the axis rotation, is going to exert a torque. In rotational momentum, L is equal to I omega, and delta L is going to be equal to torque times change in t. And remember this, when a wheel is rolling, there must be a friction because there must be a torque exerted. However, the force of friction is going to be static friction, and thus won't cause a loss of energy and won't cause work. The last thing you should know is parallel axis theorem. It is I equals to ICOM, which is center of mass, plus mr squared. I center of mass is usually provided, and you can also memorize it through these equations provided. Mr squared, m is going to be the mass, r is going to be the radius away from the center of mass, or distance away from the center of mass. Hope you have a fun time studying physics, and see you in my next video. Bye!